Hi and welcome to my channel, and in this video I'm gonna do a quick tutorial on how to solve the 4x4 axis cube. Now in order to solve this puzzle you need to be able to solve certain 3x3 shape mods such as the Master Morphics or the 3x3 axis cube, and yeah, but basically certain other shape mods might not help you as much. For example, the 3x3 Fisher cube or the 3x3 mirror cube, since they're not fully super cubes, since some of the centers don't have any specified rotation. And what's special about the 3x3 Master Morphics and the 3x3 axis cube is that every single center has a designated rotation, and yes, that's really going to help you. Obviously you also need to be able to solve a regular 3x3 cube and a 4x4 cube, and so let's begin. So the first step is we're going to reduce the centers. The centers on a 4x4 axis cube have three different types of pieces. One type is this one with two colors. Second type is a single color pieces like this. Third type of piece is three colored pieces like this. So basically each center is comprised of one piece that has three colors, one piece that has two colors, and two pieces that are a single color. And the way it works, like you could see this line here, so the proper center, this would be orange and this green and this green, and on this side we'd have one that's fully green and this side fully orange. And so what I do is first I make duos and then I attach them together. So let me show you what I mean. So for example, we have here a green, orange, white. So I need to find either a green or an orange that fits with this. Bearing in mind that we have two greens and two oranges, only one of which will fit. So for example, we have an orange here. So I bring this down to position to bring the orange into this position, and I put this here. I bring it down and it fits, which is all good and well. But let me just show you what happens if you put in the wrong one, which we have right here. So position this. If I put in the wrong one, you could see it's not flush. So you could easily tell which one's right and which one's wrong. Okay, so we have the first duo. Now the second part of this duo of the center is going to have orange and green together with a fully green piece. So we keep this, put this to the side, bearing in mind where it is in order not to break it. And okay, so we have the piece right here, green, orange, and it's matched with the wrong green, because you see it's not flush. So we look for the other green, which we have right here, and it's already positioned very easily for us. So this is positioned on the top right, this is on the top left of this center. We just bring this up, match them together, turn it aside and undo the move. The reason we're undoing it is in order not to break this duo right here. Now we turn this duo to the side, and since this is our first center, we could just bring this right in without undoing any moves. So we have our first center. Moving on to the next one. So let's say we want to make this one. So we want to put a white or a red to these pieces. So let's see, we have a white here. If I put this white on the bottom and I slide it in, I see it does not fit. But we did create this one, so let's work with this one, bearing in mind that the fixed center is right here. Okay, so we have this duo, which is red, blue, and yellow. So we need to find the red and blue piece and match it together with a solid blue. And we have the red and blue right here. Turn it this way so we can position it next to the blue. We have two blue pieces here. And we already have this constructed, so we could just turn it vertically like this, not to break it when we move things around. Turn the blues in. We see this one does not match, it's not flush, so it has to be this one. So we bring this one out to a center that we could rotate freely, that's fully broken. Bring this to the lower left part of the center, bring it back down, and we have this duo. Turn this to the left, connect it with this. Once again, at this point I know we're not breaking anything apart because of the way I have this positioned and this to the right. Okay, so now let's work with this one. Could either start with this one or this one. We already have a duo right here, so we also place this vertically in order not to break them apart. What we could even do is we could even put them in one center, so they're two fixed duos. So the way we do it is we use this one to kick this one out, flip this 180, bring it back down. Now these two are in one center. Okay, so let's see what's next. So here we have a green yellow. So we have this green yellow here. We need to connect it with a green. We have the green right here. At this point we have to start undoing moves in order not to break apart the center. So top right, put the green on the top left, bring it down, match it up, turn it aside, undo that move to restore this center, turn the cube back, and let's see. So we have this here. So we position this on the left. I'm gonna use this to kick this out, flip this, and bring it back to build the center. So I bring that duo in, flip this 180, and bring it back. We have the center, we have this one, and we have this one. We also have this duo, which is white and blue. We have a white and blue here. Need to connect it with the blue. And since this is the only blue we have, it has to be this one. So we bring, this is on the bottom right. So what we do is we bring this blue piece down, turn it so it's now on the bottom left, and bring it back up. And it connects this. Now we want to match this with this. So we bring this up, kick that one out, 180. Bring it back. We have this center. We have this duo still from before, and so we turn this aside. And what we want to do now is connect these two pieces, and the way we do it is we're going to use these two broken pieces to kick this. So we bring this red down, we're going to kick it out, and we're going to flip this down so it's going to reconnect with this properly. So we bring it up like this, and in doing so we actually made this duo as well. Turn it to the side, bring it down, made this duo, turn it like this, kick this out with this, turn it 180, bring it back. It's basic, simple 4x4 stuff, except it's just a supercube. In this case, it solved all the centers. Now we could have three situations with the last center. One is where it's fully solved, another one is where two of the pieces are swapped, and another one is where all four are swapped. So if you have all four that are swapped, you just do the following algorithm that I'm about to show you from any position, and it's going to bring you to situation number 2, which is only two of them are swapped. So let me just put it into this position so then I could show you how it works. Okay. So just by seeing this algorithm, you might already recognize it. And it's basically the regular corner swapping algorithm. You could use it on the 2x2, 3x3. I don't know about 3x3, but like you could use it to swap two corners, which is actually a 3 cycle, but it looks like it swaps two corners. And it could also be used to swap two center pieces. And so the way it works, so like I said, if you have all four of them mixed up, you do the algorithm from any position, and it's gonna bring you to this position. So the two broken ones you have on your right, the two fixed ones you have on your left. And from here, this is your top. You do a 2R. And when I do 2R, I do it straight down the middle with both right slices. You could also do it with just the middle slice or both slices, doesn't really matter. So 2R, U, only the top layer, 2R, UI, 2R, UI, D, 2R, UI, 2R, U, 2R, and DI. In this case, you don't need to do the DI, but I always do it because in some cases you need to do it. So, okay, so now all of our centers are reduced. Now we need to place them properly in conjunction with one another. So for example, if we look at these two centers, this one has red and this one has red, green under green. So these are actually positioned properly in correlation with one another. So for example, right here we need to put a piece that has a center that has green. Excuse me. So this one has green and it belongs here. So the way we do it is we swap these two centers. So we bring this up, the duo, we turn it 180, bring it back down. Now we bring this duo up from the left, turn it 180, and bring it back down, rotate this, and you could see it starts to make a cube formation, like that. And we keep going. For instance, if we turn this one in, so you have the orange and the white and the white, so it's all properly placed. This one is not properly placed because this one needs to have orange on it. So these two need to be swapped. We do it the same way. Bring it up, 180, back down. Now bring it up from the left side, 180, down. Rotate, and you could see the oranges start to make a cube formation. Rotate this one properly as well. You can see the blue starts to make a cube formation, red, green, white, and yellow. Now we start reducing the edges. The way we reduce the edges is we choose, for instance, the top. Could be any top face, doesn't matter. I'm going to use the slicing method. So the way it works, I'm going to match up edges on the middle layer, put them on the top and the bottom, and then once we get to the last four, we're going to have to use another algorithm. So this is pretty intuitive, and so let's see if we have anything that we can match up. So we have this orange and this orange that can match up. So flip this center, and now we can connect this orange with this orange here to make this, bring it to the top, replace it with another two broken edges, bring it back, and reconnect the centers of the middle slice. And we keep looking for anything else. And once again, we have here the white and the white. So we flip this 180, and we bring that white to connect with this white, bring it on top, replace it with two broken edge pieces, back down, and we reconnect the middle slices. We'll keep going. Red and red. So once again, flip this red by doing a 180 turn on this center and connect them, bring it up, replace with two broken pieces, down, and then reconnect the middles. And we keep looking. Red, green, and red, green, these two belong together. So once again, I'm gonna flip this. Red, green, bring it on top, replace it with the broken pieces, down, reconnect the middle slices. Then what else we have? Blue and blue, we don't need to flip anything, we just connect them. Could replace it with these, we'll put these in front, bring this up to the right, replace it and back down, reconnect the middle slices. Blue, yellow, these two pieces right here. So let's just see. First we could connect this orange, white without flipping anything. Make this edge, bring it on top, replace it with these two broken pieces, bring it down, reconnect our centers. And once again, turn this 180, bring the yellow, blue right here, replace it with this, bring this on top, up on the right, replace it, back down, reconnect our centers, check how many edges we've already reduced. 1, 2, 3, 4, that's on top. The bottom, 1, 2, 3, we have one more left, space for one more. Let's see if we could just connect anything right off the bat. And we can, the red, yellow, and the red, yellow. So we bring it in, and right here, we'll replace it with this. So put this right here in the front, bring it down, replace it, back up, reconnect these centers. All the edges on the bottom and all on top are reduced. Now we start using an algorithm. And so for instance, they have to be in the same layer. So we have a yellow here and a yellow here. So we use this yellow to kick this yellow out, placing it here. Do the following algorithm, which is going to flip this. So when we undo it, it's going to fix the edge. R, U, R, I, F, R, I, F, I, R. And then we bring it back, and you can see the edge is fixed. Keep doing the same way. So this green and this green, so let's say we bring this green here, we kick this one out. Same algorithm, R, U, R, I, F, R, I, F, I, R. Bring it back. Last two. So the same way, we use this one. Make sure they're in the same layer, like the blue orange is on the bottom here and it's on the bottom here. Put it in to kick it out. R, U, R, I, F, R, I, F, I, R. Reconnect the centers, and all the edges are solved. Now we reorient the centers in correlation with one another. So for example, let's say this is our top. So blue, blue, and then just make sure I have it the right way, and this one is blue as well. And then this one we rotate like this. You can see red with red, and this one red with red. So basically we rotated all the centers properly in correlation with one another. Now this is our top. I'm sorry, normally it doesn't catch this much. It's just because I'm holding it awkwardly because of the camera. But yes, so this is our top, and we're going to start putting in the edges to make our cross on top, like a 3x3 basically. So here, for instance, you have red and yellow, so red yellow piece belongs here. Where we have it right here. So we put it underneath where it needs to go. We see which way the colors are facing. So red here is on top is on the left, and yellow is on the right. And it's the same on the bottom, so this way we need to do the 90-degree turns to bring it in. What I mean is we put this off to the side, bring this down 90 degrees, bring this up to connect it 90 degrees, back up, back down. We have this here. We restored our center orientation. Red piece goes here. It's up here, so first let's put in the piece here to kick this one out. And this is blue yellow, which is right here. In this case we see yellow is on the right, blue is on the left, and here on top it's the opposite. The color is the blue is on the right, yellow is on the left. So in this way we could do a 180 turn. So first we kick it out to the side, turn this 180, put this in, turn it back up. We have the second edge. And we also kicked that blue one out now. So the blue one is right here. Put it into the bottom layer and up, and we put it underneath where it needs to go, and we see, you can see like an arrow shape. It's pointing this way, and this void arrow shape on top is pointing the opposite way. So when it's opposites, we could use the 180 method. So put this out to the side, turn this face 180 degrees, put this in, you can see it connects, turn it back up. Last one, red piece belongs here. Here it's pointing in the same direction. You can see this is kind of like arrows pointing this way. This void arrow is pointing also the same way, so you have to use the 90-degree method. So put this on the bottom, bring this down, bring this up, bring this down. I'm not getting into too much detail because you should be able to solve 3x3 shape mods, and this is pretty much the same thing. So now we put in the corners. For instance, here I see this red piece belongs here, and this red, blue, and white piece belongs here. So I'm gonna have to kick one of them out first. So I kick this one out, put it into the bottom, put in a random piece here. Now I put this piece in here. I'm gonna kick this one out. Basic 3x3 stuff. put it in, and I have the red one here. I put it in here, right here. Yellow, and I have the yellow here. Regular 3x3 shape mod algorithms. Put it in here. This one in here. Okay, so we have our first face. Flip the cube upside down now. That becomes our bottom layer. And let's see what we could put in yellow. Belongs here, but we have it. No, we actually have it on top. So okay, so we put it from here. We check from which side we need to put it in. So we have to put it in from the right side because it's going to come down like this. If we have it on the top front, it would come in inverted, so that's wrong. In this case, we put it on the top right, and we do the standard 3x3 algorithm to put it in, which is UI, FI, U, F, U, R, UI, RI. Blue orange, which is right here, belongs here. You could test it out. You could see it belongs also from the right side, so we do the same algorithm. UI, FI, U, F, U, R, UI, RI. This one also we have to put in from the right side because you can see test it out, comes in from there. UI, FI, U, F, U, R, UI, RI. Green red, it's back there. And we see also from the right side again, UI, FI, U, F, U, R, UI, RI. Now we're up to the top layer. So we look to see which edges are flipped properly and which ones are wrong. So this one you can see right away connects, so it's flipped properly. This one is in its place but flipped, so this one is flipped. This one is also in its place flipped. This one is flipped. So we have a parity where 3 are flipped and 1 is correct. So we do the regular, the Red Bull algorithm. So this is our top. We're going to turn the right slice only for this algorithm. So we do a 2R, 2B, 2U, left slice down 90 degrees, 2U, right slice down 90 degrees, 2U, right slice up 90 degrees, 2U, 2F, right slice up 90 degrees, 2F, left slice up 90 degrees, 2B, 2R, and we fix that parity. Now these two are in place, these two need to be swapped, and you could see that while ignoring the center at this point, you could see that because these connect, these two are swapped. So we place this one in the back, this one on the right, do the regular Soon algorithm, R, U, RI, U, R, 2U, RI, and back. No, my mistake. What was that? We needed to flip these two. Not. I'm sorry about that. Okay, so first let's flip them. So this is our front, this is our right, and do F, and we have basically the L shape. So these two are correct. These two need to be flipped. So we do this algorithm 2 times through. F, R, U, RI, UI, R, U, RI, UI, F. Now we do the Soon algorithm, which is going to swap these two, and it's actually going to cycle things around. So you'll see we actually have the second parity as well, and so it's R, U, RI, U, R, 2U, RI, and the final U. You can see all the edges are properly placed and solved, but this center is rotated 90 degrees. If it's rotated only 180 degrees, then we simply fix it with an algorithm, which I'm going to show you later. When it's rotated 90, that also means we have 2 corners that are in place and 2 that are swapped. In this case, you can see these 2 are in place, even though they're flipped wrong. These 2 are swapped. So to fix this parity, there's multiple ways to do it, but the simplest way, so right now this is our top layer. We turn the cube like this, so this becomes our front layer. And this is our top. So from here, we do the following algorithm, which is a common cuboid algorithm. And it's 2u with both top layers, 2r, 2f, 2u with both layers, 2u only with the top layer, 2f, 2r, 2u with both layers. That fixes the parity. Now we redo the edges, and from this position just we can do the soon algorithm. Like you can see, these 2 edges are connected. So this is our line, ignoring the center, but this is our line. So we need to flip these 2. No, my mistake. Not to flip them, we need to do the soon algorithm. So we do it from any position. U, alright, U, R, 2U, alright. And we have one that's connected. And then from here we do R, U, R, U, R, 2U, RI. And you can see it fixes it. Now, when we did that parity fix, it also flipped a center 180 degrees, which is easily fixed. And so for now, this is actually our top layer. We're going to ignore this for now. We're going to just solve the corners first. This corner is positioned in its proper place. The other 3 need to be cycled, so we do the regular corner cycling algorithm. This is on our top right, so we do U, R, UI, LI, U, RI, UI, L, and they're all in their proper place. These 2 need to be flipped, so we do RI, DI, R, D, RI, DI, R, D. We put the other corner in, RI, DI, R, D, RI, DI, R, D, RI, DI, R, D, RI, DI, R, D. Return this back. Now we just need to flip the center and the algorithm for it. So we hold this as our top layer. Do R, U, RI, U 5 times. So that was once. And again, R, U, RI, U. That's twice. R, U, RI, U 3 times. R, U, RI, U 4 times. R, U, RI, U. And we solve the 4x4 axis cube. So yeah, that's pretty much all the situations you could get on this cube. Really fun solve. And the first few solves, if this is your first time solving this puzzle, the first few are going to be quite difficult, so be prepared for that. I would say it takes at least 10 solves until you start to get comfortable with it, and probably 20-30 solves down the line you should start to be comfortable enough where you could solve it fairly easily without losing your perspective. So yeah, that's pretty much it. If you have any questions, please feel free to ask. And in the meantime, thanks for watching, and until next time.